Hi, Ms. Torres. This is Danny from Period 1, and I will be doing the 5-1 through 5-4 test corrections. And since this was a calculator-based test, I will also be using a calculator. This first problem is on the back side, the first one from the top. So find the f inverse prime of 3 for the function f of x equals to 3 over 5 x to the fifth plus 7 over 3 x third minus 3. So we know that whenever we are finding the derivative of an inverse, we have the function, we have the rule that's f inverse prime equals to 1 over f prime of f inverse. So first step, we have to find the inverse. So when finding the inverse, we have to set 3 equals to the function. And that is because although this is supposed to be the y value, when we're finding inverse of it, we know that the x and y's can flip. Since for a normal function, it would be x comma y. For inverse, it would be y comma x. So 3 would actually be the y in this case. So finding that, we would have 6 equals to 3 over 5 x to the fifth plus 7 over 3 x third. And after multiplying everything by 15, we get 900 equals to 9x to the fifth plus 35x third. And in order to find x, I'll be plugging this into the calculator and graphing it, which would be 9x to the fifth plus 35x to the third minus 900. And I'll be finding where it hits the x-axis, which is also the x value. So there's the graph. So I'm going to hit second calc 0 and put in a left bound, left bound, and then putting in a right bound and finding 0 equals to 2.239, which is also 2.24. So after getting x equals to 2.24, we already have f inverse. So now we have to find f prime of 2.24. So first we take the derivative of the original function, which is 3x to the fifth plus 3x to the fourth plus 7x squared, and that would be f prime. So plugging in 2.24 into x, I'll also use the calculator to do. So first I'm going to enter in the function 3x to the fourth plus 7x squared. And then after setting x as 2.24, I'll go back to the equation, function, and get 110.65. So f prime of 2.24 equals to 110.65. After getting that, I already have the entire bottom part figured out. So now I know that f inverse prime of 3 would equal 1 over 110.65, and that would be 0.009, which would be the final answer. Okay, for the back one, this is the last problem in the test. And since velocity has to be in a squared minus or plus a t to the first power, due to some physics formulas, I couldn't change the powers of these, so all I did was change the numbers here. So a particle travels along a line. Its velocity in meters per second is given by v of t equals to 6t squared minus 36t. So part A, find the displacement from t equals to 2 to t equals to 12. So displacement is basically finding what x is, and since we know that the derivative of x would equal to t, and I mean v of t, and the derivative of v of t would equal to a of t. So since we have v of t, in order to find the actual displacement, I'm going to do the integral of it, and the bounds would be from 2 to 12. And doing the integral would get me 6t cubed over 3 minus 36t squared over 2 from 2 to 12, which would be the same as 2t squared, 2t cubed minus 18t squared from 2 to 12. And plugging 12 into the function of 2t squared minus 2t cubed minus 18t squared, and after setting 12 as x, I would get 864. So 864 minus the bottom, which 2 would be x now, and the function would give me negative 56, and negative 56, this would be plus, so 864 plus 56 would be 920, so that would be the answer for the first one. And part B, the distance traveled by the particle from t equals to 2 to t equals to 12. Since we know that distance, it could be positive displacement and negative displacement added together, we have to find areas where the particle changes direction. So in order to do that, I would find 6t squared minus 36t equals to 0 and find t. So 6t squared minus 36t equals to 0. That would be 6t squared equals to 36t. T's will cancel out, and that would be 6t equals to 36, and t would equal to 6. So at t equals to 6, I know that the particle changes direction, so I will do integral from 2 to 6. 6t squared minus 36t plus integral 6 to 12 6t squared minus 36t dt. And this is also dt here. Okay, so doing that will give me 2t cubed minus 18t squared 2 to 6 plus 2t cubed minus 18t squared 6 to 12. So since we know that 2 is already negative 56, just go ahead and put in that, and 12 is already 864, so plug in that. Alright, so putting in 6 would get me negative 216. So negative 216 plus 864 minus negative 216, and getting that will give me negative 216 plus 56, which is negative 160 plus 864 plus 216, which is 1080. And from that, we know that distance cannot be negative, so we would have to take the absolute value of whatever is negative here. And getting that would be 160 plus 1080. And that would give me 1,240 meters. And this would be meters. Okay, and the last one, part C, is the speed increasing or decreasing at t equals to 8? Justify. We know that whenever the acceleration and the velocity of it is the same, the particle is increasing, the speed is increasing. However, if it's different, then speed is decreasing. So with this, acceleration at 8 would equal to taking the derivative of this, which would be 12t minus 36, and putting 8 in for t, that would give me 96. So 96 minus 36, that would be a positive number at the end. So I know that my acceleration is positive. Now for v of t, so v of 8 equals to 6t squared minus 36t. Alright, plugging in 8. Okay, so 8 stored as x. That would give me negative 128, which is negative. So the speed is decreasing. And that's the end of the test corrections. Thanks.